Welcome to TechStack.io. This is Venkat. In this video, I'm going to talk about object-oriented programming. So we are going to cover the main concepts of object-oriented programming. This is going to be a series of videos which is going to cover the main concepts of object-oriented programming like classes, objects, encapsulation, inheritance, polymorphism, and abstraction. So this video mainly focus on class and objects. Let's get started. So what is object-oriented programming? Object-oriented programming is a programming paradigm based on the concepts of classes and objects. Yes, it's everything about classes and objects. The main basic idea is to separate a complex software application or a program into a bunch of objects talking to each other. What is an object? An object is a real world entity. So the examples can be like a bicycle, a car, a person, a dog, a bank account, etc. So if you see all these real world objects, they share two main characteristics. So take an example of a car. A car has a color. What is the model of the car? Which year it has manufactured? So this defines the state of a object, state of the car, and what actions we can perform on the car, like you can start the engine, like stop the car, park the car. So let's take an example of a person. A person has a name and email, so this defines the state of a person. And a person can walk, jump, run, and dance. So this defines the behavior of a person, right? So software objects are conceptually similar to the real world objects. They also consist of state and objects, and in fact the real world objects can be represented into a software objects. So a software object stores its states in the form of fields, and we also call fields as variables, and exposes its behavior through methods. So methods can also be called as functions. But how can we create these software objects? Class. Yes, we need a class to create a software objects. What is a class? A class is a blueprint for creating the objects. Let's take an So we have a class called bicycle, and the class is defined using a keyword as class, and we have a name like bicycle. So the name of the class and the file name should always match. And take a look into these fields. Like we have three fields in this class. So a name which has a data type of string, and current speed and current gear that has data type as integer. So these three fields defines the state of the class, right? So how can you change the speed and how can you change the gear? Yes, that's where the methods come into the picture. So let's take a look into the method like set current speed, where it takes a current speed as a parameter and it is setting into the current speed fields. So you can use you can use set current speed method to change the state of the bicycle, to change the state of the current speed. So similarly, to change the current gear, you can use set current gear method, which takes the current gear parameter and you can change that. So let's create an object out of this class and see like how we can change the state of a object. So I have a bicycle this application here, and I'm going to create a bicycle object using bicycle class. So I'm naming this bicycle1. So using new operator, I'm going to create an object. So let's name this bicycle1. The speed I'm setting into 10, and what is the gear? The current gear is 1. So let's try to print on what values we are going to get. I'm printing the values: bicycle name, bicycle dot get name. So let's print current speed and current gear as well. So bicycle current speed, bicycle1 dot get current speed, and what is this one? So bicycle current gear, so bicycle1 dot current gear. So let's run this program, and here we can see the name of the bicycle is bicycle1, and we can see the speed is 10 and current gear is 1. So make it more clear, let me add some space and run the program again. Yes, you can see the name of the bicycle is bicycle 1, 10, and none. So this is how the object is created. And now, so you can create as many objects you want. So I'm going to create a second object. I'm just copying that and name this object with bicycle 2, and I'm setting the current speed as 20 and current gear as 2. So let's use the bicycle 2 object and print the values now. So let me save this and I'm going to run this program. Yes, as you can see here, so we have created two objects. So with name bicycle 1 current speed and gear 1, and bicycle 2 has current speed and 20 and gear 2. Yes, so we can create as many objects you want using a class. So if you see, the class is just a blueprint for creating the objects, right? So now I want to change the bicycle 1 state. So how can I change? Yes, we can use the methods to change the state of an object. So bicycle 1 dot set current speed, I am changing to 30, and bicycle 1, let's change the gear to 3. So now run this program, and now see the state, the speed of the bicycle 1 has changed to 30 and gear is changed to 3. So this is how we can change the state of a bicycle by using the methods, right? Yeah, so this is all about the fields and methods, and now we are going to see about the constructors. So the constructors are mainly like, so we have mainly two constructors. One is default constructor and parameterized constructor. So in this example, what we have seen in this example, we have used the parameterized constructor where we are passing the name of the bicycle, current speed and current gear to initialize it. So let me uncomment this and see, and let's use the default constructor. So let me uncomment this. Yes, I'm going to uncomment, I'm going to comment this bicycle, and here obviously it's going to complain because we have just comment out that parameterized constructor. And let me comment out this bicycle 1 for now, and also the bicycle 2 which is using the parameterized constructor. And now create a bicycle 2 object using default constructor, and now try to run this program. Yes, so now you see you don't have a name, speed and gear, right? Because we created an object but there are no values set. So in case of parameterized constructor, we are passing the bicycle name, speed and gear to set the values, but whereas in default constructor we are not setting any values. So let's try to set values. Current, the name, so we are setting the name as bicycle 2, and set the current gear, the current speed as 20, and similarly set the current gear as 2. And now just run this program. Yes, so now the values has been set, and now we are seeing the bicycle 2 speed is 20 and gear is 2. So if you take closely in this bicycle object, here we don't have any constructor. So but still the compiler does not complain about this default constructor. Yes, so if you don't have any constructor in an object, in a class, the compiler does automatically create a default constructor for you. So this is what the default constructor is. So we don't have any constructor here, we have comment out this, and now the default constructor we are able to create the object. So let's uncomment this parameterized constructor and see what happens. You see, so this is complaining, right? So what happens here is that, so when you define a parameterized constructor, the compiler does not provide you any default constructor, right? So it says like, yes, you already have a constructor, so I'm not going to provide any constructor for you. So how can we fix this? Yes, we can fix this by having a constructor which does not take any parameters. So if you don't have any parameterized constructor, a compiler provides you a default constructor which looks like the same thing like this, But if you want a constructor which does not take any parameters like a default constructor, you have to explicitly mention it if you are also having a parameterized constructor. So now let's uncomment this, the bicycle 1, and run the same program again and see like what values we are going to get. Yeah, so here we can see the bicycle 1 has a speed 30 and gear 3, and bicycle 2 is 20 and 2. So bicycle 1 is created using parameterized constructor, and bicycle 2 is created using default constructor. So this is all about the constructors. Now let's take close look into the access modifiers. So we have like 4 types of access modifiers: a private, public, protected, and default. So it's always a best practice to define the fields using private. A private access modifier can be accessible only within the class, and these fields, the private fields or private methods cannot be accessed outside of the class. So we are going to cover why we define fields always as private in encapsulation section in the next video. But now just remember that it's always a best practice to define the fields using private access modifier, and methods that expose the behavior to outside of this class can be we can use public access modifiers. So in case of private, this is accessible only within the class, but in case of public, these public fields or public methods can be accessible anywhere, even in the package or outside the package as well. So but what about protected? So protected keywords lies between somewhere between the private and the public. So protected is accessible throughout the package. Inside the take for example, like so we have bicycle class in the package of OOP, like org.extract.io.oop. So if you define this field like protected, this is accessible throughout the package, and it is also accessible in other packages if it is a subclass of this. So we will see that subclasses and main classes in the section of inheritance. And now we have a default keyword as well. So if we don't define any keyword like this, and this is nothing but a default access modifier. So the default access modifier can be accessed only within the package. They cannot be accessed outside of the package even if it is a subclass. Yes, so that's all about these classes and objects. Thank you, and see you in next video.